Using the definition of derivative to calculate every time, that can be quite tedious. So it's better to have some shortcuts or derivative rules. If you take the derivative of a sum of two functions, that is just taking the derivative of each. And similarly for the difference, you just take the difference of the derivatives. If you take the product of two functions, then the derivative of the product is given by the sum of these two, where you first take the derivative of the first function, and then you take the derivative of the second function. If you take the quotient of two functions, then the derivative is similarly given as this. So this far is the same as the product, but then you have minus here instead. And also you have to divide by the square of g. Let's take some examples of these rules. Let f of x be this and g of x be this. So if you take the derivative of the sum, that's just the sum of the derivatives. And this one we have seen to be equal to slope 3. And this one is equal to 2x, as we have seen. In the same way, we have the derivative of the difference is given by this. So the derivative of the first one minus the derivative of the second one. And again, this is equal to 3 minus 2x. If we take a derivative of the product of the two functions, then according to the rule, we should first take the derivative of the first one. Then multiply by the second function. And then we take the derivative of the second function. And multiply with the first function. Now we have seen this is equal to 3. This is equal to 2x. So this simplifies to which in turn can be simplified to 9x squared plus 8x. Finally, we have for division. Then we start off in the same way as here. So we just copy what's written here, but we put minus instead. So we get this one. And then we should also divide by the square of the denominator. This one here we have basically already calculated here. You just have to switch the sign here. So here I've taken this one, put the minus here, and then I have this. And this one is x to the 4th. Since it's x to the 2 times 2. And here we get this, which simplifies to which in turn simplifies to and this is the result. This is the derivative of this. Then we also have some other rules here. For example, if you take the derivative of a power of x, so here n is a constant. So if you take the derivative of that, then the rule says that it is given by n times x to the power of n minus 1. And this can be proved, but we won't do that here. We have seen already a special case of this. So when this was x squared, we saw that this was equal to 2x. And that's just a special case of this, because here 2, that's the n, and here I have x to the 1, and 1 is 1 less than 2. Another special case is this one. So if you have a constant times a function, and you take the derivative of that, then it's just to multiply the constant with the derivative of the function. This is just a special case of the product rule. So if you let the first one here be constant, then that rule will just follow from this one. But it's good to have it written explicitly down. So when you have a constant in front of a function, the constant just follows along. So let's see examples of this. For example, if we have x to the third and take the derivative of that, then according to the first rule, then we get 3 in front, and then we have 3 minus 1, and this is just 3x squared. And if you use both rules together, so if you take the derivative of this function, then first we see that we have a constant in front, so you can use the second rule. So the constant just follows along passively. So we just need to take the derivative of the second one. And according to this rule here, this becomes 4 times x to 4 minus 1. Or this is just 3. So this simplifies to 20x to the third. Note that the special case of this is if you take the derivative of just x, then x can be written as x to the power of 1. Then we can use this rule here, and that just gives us 1 in front and 1 minus 1, and this is 0. And x to the power of 0, that's just 1. But that we already knew from another case, because take the derivative of x is equal to 1. It also follows because this is a straight line with slope 1. So it could be written as 1 times x plus 0. And you know that if you take the derivative of that, we know that this is equal to the slope 1. Then the final rule we will look at is to take the derivative of a composition of two functions. So if you have a function where you put in another function, so this is a composition of f and g, and if you take the derivative of that, then that is given by the following rule. First, you need to take the derivative of f and then put in g or x into that. Then you need to multiply by the derivative of g. So let us take an example. So let's say we want to take the derivative of this function. This is a composition of two functions. Here f is equal to this one, that is the outer function. Then g or x is the inner function. So if you put g or x into the place of y here, that is, you take this one and replace y there, then we get this function here. So that means that this function here is f of g of x. So if we now want to take the derivative of this one, we first need to take the derivative of the function f, this one. So that basically means that we should, for the moment, forget about what is written inside the parentheses and look at this as just one big y. So here stands then y to the 5. And if you take the derivative of that, then we have from this rule here that we should write 5 and then to the power of 4, 1 less than 5. So if you for a moment forget about it, it's written something here. So you can think of it like this. Then it sets something to the power of 5. Then we take the derivative of that. That's 5 drop down and have 1 less here, 4. And after we have done that, we put back this in. So that corresponds to this one here. Then we should take the derivative of g. And that's just taking a derivative of this one, which means taking the derivative of the one inside the parenthesis here. So this becomes 3, since that's just the slope of a straight line. And this we just keep at the moment. And then if you simplify, we get this. Let's take another example of that rule. So let's say we want to take the derivative of this function. Since we don't know how to take the derivative of a square root, let us first express it in a different way. Square root of something is the same as taking that something to the power of a half. And here we have a composition of two functions. The outer function, which is something taken to the power of a half. So you have something written here. Then the inner function, that's inside the parenthesis, is this one. So this corresponds to g, this corresponds to f. If you combine these two, you get this one. So taking a derivative of this one, meaning that one, that is the same as taking the derivative of composition of two functions. And that's just this rule here. So to take the derivative of this one is the same as taking the derivative of this one. And now we can use the rule we have seen before. And that rule was this one. So if you take the derivative of a variable raised to the power of n, then n drops down and you get 1 less on n. In here it doesn't matter actually if n is an integer or not. So it also works for a half. And it even works for a decimal number. So first of all, now we should take the derivative of the outer function. That is, if we forget about what's written here and just look at this as one big variable raised to the power of half. So then we have this example where we have something raised to the power n. So we just need to copy this one here. Then we see that we get a half in front. That's n. And then we get this one raised to the power of a half minus 1. So here we have just used this rule here. But now we should put that back in here. For after we have finished, this is what should be standing here. So that is the outer derivative, so to say. This is this part here. We call it the outer derivative. And this one we call it inner derivative. And that's what's left now. Then we need to take the inner derivative. So that's the derivative of that's inside here, the parenthesis. So let's simplify this first. This is minus a half. And this one is just the derivative of each of these two functions. And the first one is 4x to the third. Again, according to this rule. Then we take the derivative of 1, but that's just a constant function, so that's 0. Then we have done all the derivatives. Then we only need to simplify this. So first of all we get this one. And the minus here just means to put that in the denominator. So that becomes this. And this one here, that's just a square root. So we end up with this one. So this is the derivative of this one here.